expect? Now, for the fact that they're asking you how much can you expect, right? So they want you to find the expectation, right? Under basic statistics, how do you find the expectation? The second formula, okay? Which is, I can change also this question and be like, what is the average, right? Still the expectation. So how do you find the expectation? The summation of xi times the probability, right? Okay, let's move from that. Let's not do question 3. Question 3 is based on chapter 1, so don't do that. Now look at question 4, which is more interesting. Are you still in chapter 4? That's the first question that you need to ask yourself in test 2. Are you still in chapter 4? We're doing test 2, semester 2, 2018, right? Which is just last year, the same time. Okay, guys, are we still on chapter 4? We're looking at question 4 now, right? Are we still on chapter 4? What determined that you're in chapter 4? It's what you're given, right? Okay, so are you still on chapter 4? The answer is it's either yes or no, right? Are we still on chapter 4? Yes, no's. Come on, guys. Guys, the reason you attend SI and you need to take into advantage of these things. You see, you're a small group here, right? Compared to classes and stuff. So if you're here and you see a small group, you need to be happy because this is where you can actually ask questions. And if you don't understand, say, I just don't understand anything, right? Okay. So are you still on chapter 4? So you say a bold yes. If it's a no, you say a bold no, right? Then I'll say my answer also, because the way you teach people, I need to understand how you think before I can help you, right? Okay, so question 4, yes. Yes? No? Do we have a no? Do we have a I don't know? Yeah, we have an I don't know. So now, you see now, this is now the problem. Why we mustn't rush going to chapter 5 if there are things we don't understand about chapter 4, right? So allow me to just do chapter 4 again, and if maybe you're okay with chapter 4, you can be excused, right? Okay, can I have a tissue? I love from chapter 4, chapter 5, 6, and I love those chapters. I hate chapter 3. I hate it. So can I erase here? Okay? Again, these are the reasons why you need to join the private sessions, because in those sessions you get a chance to talk to me like in person, one-on-one, and the people that are in that group, they find out chapter 4. But if you only on the SI, you get to see me on Thursdays only, or on Monday, right? But those guys see me every day. Okay? Again, if you can't afford to be on the private session, get someone who can afford, then you'll also be on the session, just like that, or just get 75% and above. Okay, if chapter 4, guys, chapter 4 is discrete data, which is countable data. We find about that. This countable data now we've got chapter 4 as basic statistic. There's also what is known as probability distributions. T distributions, right? You also have approximations. And you still have a lot of time. You're writing your test 2 in October, so make sure you polish everything. So basic statistics, how do you see that a question is based on basic statistics? It will be given in a form of a table, right? So it will be given in the form of a table where you are given discrete variables, And along these discrete variables, you're given probability of occurrence. Probability, right? The examples that we've just did, right? The examples that we've just did, what is this? This is a table. And this table you're given probability of occurrence, right? And in question 2, you're also given a table. Along this table, you are given probability of occurrence, right? Okay, so this is under basic statistics. Now, if it's under basic statistics, what do you need to understand? 1, 2, 3, right? Only these 3. Where these 3 also are on your formula sheet. Yeah. Also, I can give you this same thing, just give you random numbers, -6, -4.5, -0.3, and respectively, I give you the probabilities, right? Still the same thing, you can change this to be the table, okay? So, again, that falls under basic statistics. Let's talk about probability distributions. Probability distributions. Okay, probability distributions. Let's talk about that. There are now, guys, probability distributions. Right? You've got binomial distribution. So every question that will answer in this question paper will answer it manually using the table and also use Excel, right? Okay. So we've got binomial distribution. You've got Poisson distribution. You also have hypergeometric distribution. Right? Okay. Now, fine. In this case, you're being given discrete data, right? Firstly, let's talk about this distribution here, right? Distribution here, which is binomial. Distribution. Right? Binomial distribution. Okay? Right. So you, like in basic statistics, what do you have? You've got discrete data, you've got countable data, like 1, 2, 3, these are countable data. They're finite, you know where they start and where they end. That's fine. And under those discrete variables, you're being told their probability of occurrence. That's fine. Whether you're given in a form of CDF or PMF, that's fine. But what if I tell you that in a die, I'll tell you like this, n is equals to 6, rolling a die, right? And the probability of success is 1/6. The probability of success is everything that's there on your sample space being of occurrence, right? It's 1/6, okay? If you're only given these 2, right, you know you're dealing with binomial distribution. So from a given statement is different from a question. A statement, you'll have a full stop. A question, you'll have a question mark, right? So look at question 4 here. What are you given? Question 4. Over his career, Michael Jordan, a basketball player, scored points in 75%. The percentage is the same as the probability, right? Okay, of the games in which he played. A random sample of 20 of his games is selected, right? So do you see a question mark there? No. So this is a statement. Everything that's here is a statement, right? What are you given from the statement? Probability. That probability is referred as the probability of success, right? So this is the probability of Michael Jordan scoring, right? So 75 of the games that Michael Jordan has played, 75% of the time, he scores, right? Okay, then you're also given a sample of 20. Okay, so you've got okay, you will be getting your pictures on the Instagram page, right? So don't worry. So pictures for free, camera pictures for free. Okay, now again, it's not just, guys, it's not, this being binomial distribution does not only depend on the fact that you're only given these two, right? Obviously, you need to understand this is probability of success, okay? And this is your sample. It becomes binomially distributed. The discrete variable becomes binomially distributed if the probability of occurrence of every variable that's there in the sample space is the same, right? For a die has 6 outcomes, and the probability of any variables to occur is 1/6, so it's the same, right? If that's the case, you're dealing with binomial distribution. But in simple terms, if you're given probability and your sample, it's binomial distribution. Go to your tables now. Let's answer this question. Question 4. Right? Go to your tables now. Table, you don't have, right? Guys, I'm always giving out tables.
I returned them.
People, I'm sure you've got tables in your rooms now. Go to binomial distribution, you don't have. All the time, I'm giving out tables. All the time.
You returned them.
No. Okay. Now, if you look, okay, guys. Again, I want you guys, because you attend SIs and stuff, I want you guys to understand the little things that are happening in stats. Look at these tables. Number one, how do you see that these tables are for binomial distribution? It's written on the top, obviously, so that's fine. Yeah? Oh, alright. So the line, hey, mess, not good. Okay, so it's written on the top, that's fine. But you need to understand that these tables are statistical tables, right? And these tables give you the error to the left, right? Or should I say give you the probability of to the left, meaning they give you the CDF, right? Remember the CDF?
Yes.
Right? Okay. So if you look at how do I see that? If you look at the PDF of this binomial distribution, if you look at right at the, okay, it depends how you're looking at it. But on my right hand side, right at the top, you've got a binomial distribution PDF. This is known as the PDF, right? Probability density function, right? Every distribution has its own PDF, right? So if you look there, right, on my right hand side, you see this, right? What does this mean? It means that every probability or area, if I can call it like that, is to the left. Okay? Okay. That's why, okay, but we'll come to that. Now let's answer this question. What is the probability? Okay, you want to find the probability? I write P, right? For probability, okay? What's the probability that Michael Jordan scored points in under 13 of the games? Under, what does under mean? Less than. Is it less than or equals to or less than? Less than, right? So what is X? Number of games, right? And this X is discrete. Why is it discrete? Because you're in chapter 4, right? And how do you see that it's discrete? Can you have a number of games which is 1.5?
No.
So this is where the discrete comes from, right? Which is, you're saying less than, right? Because of under. So you're saying 18, right? How do you know that the probability they've given you is of success?
Why 13?
Under 13 of the games.
Oh, okay.
Okay, how do you know that the probability they've given you is of success? You know that when you read the questions. Right? Let me change this question. If the question was, what is the probability that Michael Jordan did not score points to under 30 goals, did not score points, right? So the question is interested in Michael Jordan not scoring points, but the probability given is based on Michael Jordan scoring, right? So the probability, that means the probability given is not the probability of success, right? So the probability of success is Michael Jordan not scoring, right? So I know it's the probability of success based on the question. Okay. So this is the same as, 13 is not included here. So this is probability of X, again, games, random variables, okay? Being less than or equal to 12, right? So then what do I do? Okay, there are two ways I can ask you a question in chapter 4. It's either I ask you a question based on equality or based on inequality, right? This is inequality, this is equality, right? So if I ask you the question based on equality, you'll need to use the PDF of that distribution. If I ask you a question based on inequality, you need to use the tables to make life easy, right? You can use the PDF, but this will take much of your time. So rather use tables. Okay, since the question here is based on inequality, what do I need to use? Tables. Under binomial distribution, right? Okay, so let's use the tables then. Okay. Yeah. So also these guys will be now on the private sessions and stuff, taking pictures there for people to see themselves, and yeah. Okay, are we able to look at the table? Anyone who doesn't know how to look at the table?
The P that we use is...
You're using 0.75 because the question is based on Michael Jordan scoring. So the 0.75 is the probability of success, right? Why is it the probability of success? It's because, okay, every game that Michael Jordan plays, which is discrete, the probability of him scoring is the same for every game, right? So this becomes binomial distribution by that the probability of success is the same for every variable that's there, which is nice, right? So how can you see that again? If you can say, let me see, can you go me? Okay, why do you use that? 0.75. Okay. So what's the answer, guys?
What is our N?
What is your N? N is 20. 20 games. What is your X? 12. What is your P? 0.75. You can't be asking what is your N. Why are you using binomial distribution if you don't know your N? Because given your N and your probability of success, that's why you're using binomial distribution. Please sign. Yeah. So, guys, are we winning? Winning. Can I move on? Can I? Okay. What if I change this? Can I change this to be greater than?
Yeah.
Find me the probability of Michael Jordan scoring. Okay. Now, find me the probability of Michael Jordan scoring at least 18 of the games. So at least it's greater or equals to 13, right? So this is equals to 1 minus probability of X being less than or equals to 12, right? Why do you say 1 minus?
Because that's always to the right.
Yeah, it's to the right, and you understand that these tables give you the error to the left, so you need to convert, right? So that's why you say 1 minus. Why are you saying 1 minus? Why not 2?
probability is between 0 and 1.
It's because you understand that you remember from discrete, right? The summation of probability of x is equals to xi is equals to 1, right? Why is it 1? It's because you understand that if the probability is 1, that means you're sure that this will okay, right? This discrete variable will okay? So that's why you say it's 1, okay? So again here, you're saying 1 minus, it's because you understand that the probability of Michael Jordan will play, right? And the probability of saying 1 rather than 2 is because you understand that Michael Jordan will score in one of the games. It mustn't be this game today, but out of 20 games, Michael Jordan will score, right? So that's why we say 1 minus